Hi guys! Today let's talk about exact differential equations. Before we proceed with the formal definition of an exact differential equation, let's first take a look on this function f, which is a function of the two real variables x and y. Take note that if we have a function of two variables, that represents a surface. And if that function is equal to a constant, that represents a level curve or what is commonly known also as the contour curve. If we are asked to solve for the total differential of this function, dahil dalawa yung variable niya, yung derivative natin is with respect to two variables. Paano ba kinukuha yung total differential ng isang function na may more than one variable? What we'll do is we'll take the derivative with respect to one variable, then later, we'll take the derivative with respect to the other variable. So first, let's take the derivative with respect to x. If we're taking the derivative with respect to more than one variable, we'll be using this symbol instead of d. So let's say the partial derivative of f with respect to x. So pag kumukuha tayo ng derivative, di ba yun yung tinatawag din nating rate of change. Kapag with respect to x, yung ating differentiation, lahat ng variables aside from x will be taken or held as constant. For this, yung other variable lang naman is y. So si y, kapag nag-differentiate tayo with respect kay x, kino-consider natin siya as constant. Let's take the partial derivative of the first term with respect to x. Y squared will be constant, so hindi natin siya i-differentiate. Multiplied by x, so derivative ng x ay 1 or sulat natin as dx. Plus, for the second term, we have 2xy cubed. So, si 2 constant, y is also considered as constant. Derivative ng x ay dx. So, factor out natin si dx dito. So, the partial derivative of f with respect to x is y squared plus 2y cubed dx. Next, let's take the partial derivative of f with respect to the other variable, which is y. So, dahil ang differentiation ay with respect kay y, lahat ng x ay taken as constant. So, x is constant, derivative ng y squared is 2y dy, plus, for the second term, 2 constant, x is again held constant, derivative ng y cube is 3, y squared dy. Simplify lang natin to. So, we'll get 2xy plus, for the second term, 6x y squared quantity dy. To get the total differential of the function f, we'll just add the partial derivative with respect to x and the partial derivative of f with respect to y. So, the total differential of f is equal to y squared plus 2y cubed dx plus 2xy plus 6xy squared dy. If we define the total differential of a function f in terms of two variables, x and y, that is equal to the partial derivative of f with respect to x plus the partial derivative of f with respect to y dy. If we have a differential equation in this form, we can say that it is exact if there exists a function in two real variables x and y such that the total differential of that function is equal to the left-hand side of the differential equation. We can see that the function f in terms of the two variables x and y is equal to c because the right-hand side of the equation is equal to 0. So the total differential is equal to the derivative of the constant, and we know that the derivative of a constant is equal to 0. Previously, we've also learned that the total differential is equal to the partial derivative of the function with respect to x dx plus the partial derivative of f with respect to y dy. If we compare these two equations, we can see that m is equal to the partial of f with respect to x and n is equal to the partial of f with respect to y. If we take the partial derivative of this with respect to y, we can also show that the partial of m with respect to y, that is equal to the second partial of f with respect to x and y. In the same way, if we take the partial derivative of this equation with respect to x, we can see that the partial of n with respect to x is equal to the second partial of f with respect to x and y. We can see here that it is equal, therefore, the left-hand side are also equal. So from this, we can come up with the condition for exactness. So if we have a differential equation in the form m as a function of x and y dx plus n as a function of y dy equals 0, if the partial of m with respect to x is equal to the partial of n with respect to y, then the differential is exact. That means that the left-hand side of the differential equation is the total differential of some function. Our goal now is to find or determine that equation that has the total differential equal to m dx plus n dy. Let's consider this differential equation, quantity 2xy minus 3x squared dx plus quantity x squared plus y dy equals 0. As you can see, yung form niya is of the form na m dx plus n dy. So we can set this as m and this as n. First step that we'll do is to check if this equation is exact. To check that, we'll use the condition for exactness. So the test for exactness, tingnan natin kung yung partial ba ni m with respect kay y ay equal sa partial ni n with respect kay x. Kunin natin yung partial derivative ng terms na to with respect kay y. So the partial of m with respect to y is equal to, so these terms, si 2xy, again, kung hindi siya yung variable na dinidifferentiate natin, iti-take natin siya as constant. Therefore, si x here ay iti-take natin as constant. So ang derivative ni y ay 1 minus partial derivative of 3x squared. So dahil ito ay x, consider natin siya as constant. Therefore, the derivative is 0. So simplifying this is just equal to 2x. Next, check naman natin yung partial ni n with respect kay x. So, partial derivative of x squared is 2x. Partial derivative of y with respect kay x. So, dahil hindi siya x, detake natin siya as a constant, kaya ang derivative niya ay 0. Again, simplifying this. Therefore, dahil equal yung partial ni m with respect kay y sa partial ni n with respect kay x, the equation is exact. Kailangan natin mahanap ngayon yung function f ng total differential ay equal dito. Previously, we've defined that the total differential of f is equal to partial of f with respect to x dx plus partial of f with respect to y dy. So, comparing this with this, dahil exact siya, alam natin na may nag-exist na isang function na f ng total differential ay equal dito. We can see that partial of f with respect kay x ay equal kay m. And this with this, so partial of f with respect to y is equal to x squared plus y. Paano natin ngayon mahahanap yung function na f? To find the function f, consider muna natin itong equation na to. What if we integrate this with respect kay x? So partial of f equals 2xy minus 3x squared partial of x. So integrate natin to para mapalabas natin si function f. So, integrating the left side, integral ng differential ng f, that is just the function f. So, that is a function of the variables x and y equals, kapag nag-integrate tayo with respect to a one variable, lahat ng variable na hindi iyon, iti-take natin as constant. So, pwede natin siyang i-relate kanina dun sa pag-take ng partial derivative, wherein kung hindi siya yung variable, kung saan tayo kumukuha ng derivative, i-consider natin siya as constant. So, for this case, ang integration is with respect kay x, lahat ng y, iti-take natin as constant. So, 2y, that will be considered as constant. Take the integral of x by power rule, that is x squared over 2 minus, so ito x lang naman, so constant si 3. Integral of x squared is x cubed over 3 plus, imagine niyo na itong ating integration na pinerform ay parang indefinite integration wherein nag-add tayo ng constant c. Bakit tayo nag-add ng constant c? Kasi pag nag-differentiate tayo ng constant c, di ba nakakancel siya, nagiging 0? So dito, dahil ang integration ay with respect kay x, kailangan magdagdag tayo ng function ng y. Dahil kanina, nung dinifferentiate siya, baka merong function na y doon na tinake as constant. So nung dinifferentiate siya, naging 0. So kaya nagdadagdag tayo ng function ng y. Simplify lang natin to. So we have here, we can cancel this. X squared y minus x cubed plus the function y. So ito in terms of y lang. Yung original function natin na hinahanap ay in terms of x and y. So ito na ngayon yung ating hinahanap na function. Kaya lang meron pang unknown function dito na u. So by using this, take natin yung partial derivative ni f with respect kay y, then i-equate natin with this. So take natin to. Partial of f with respect to y is equal to partial derivative of x squared y with respect to y. So lahat ng hindi y considered na constant, meaning x squared ay constant. Then just take the derivative of y with respect to y, that is 1, minus derivative ng x squared with respect to y, taken as constant, 0. Plus, derivative ng u as a function of y with respect to y. So, that will be the first derivative of that function. So, u prime y. And we know that that is equal to this. X squared plus y. So taking a look at this equation, we can cancel x squared. Ano na lang yung matitira sa atin? Ang matitira sa atin ngayon is this. U prime as a function of y is equal to y. Para makuha natin si u, anong gagawin natin? So again, we'll integrate. So imagine nyo to, pwede siyang isulat as the derivative of the function u with respect to y that is equal to the integral of y. So taking a look at this, para tayong merong variable, separable, na differential equation. This is y dy. So integrating both sides of this equation, we can see that u is equal to y squared over 2. So ipalit natin to dun sa kaninang function ng y. Ito yung nakuha nating function kanina. Ipalit lang natin itong nakuha nating u as a function of y. So the function that we're looking for is just x squared y minus x cubed plus y squared over 2, and that is equal to a constant. Previously, diniscuss natin na dahil equal sa 0, meaning pag dinifferentiate may constant, equal sa 0. So pag integrate mo siya, that is just equal to this. To remove this denominator, so lagyan ko na to ng over 2. Then multiplying the whole equation by 2. We have here 2x squared y minus 2x cubed plus y squared, that is equal to c. So this is now the general solution of the differential equation that we have. Problem number 2, let's try to solve for the general solution of this differential equation, 2xy dx plus quantity y squared plus x squared dy equals 0. Ang format niya ulit ngayon is m dx plus n dy equals 0. Meaning, we set this as m and these terms as n. First step is to check kung siya ba ay exact. M is equal to 2xy and n is equal to y squared plus x squared. To check kung siya ay exact, kunin natin yung partial derivative ni m with respect kay y. So para hindi kayo malito, sino ba yung dinidifferentiate mo with respect kay x or kay y? Yung kasamahan ni dx, i-differentiate mo with respect kay y. Yung kasamahan ni dy, i-differentiate mo with respect kay x. So, i-take natin yung derivative nito with respect kay y. So, lahat ng hindi y is taken as constant. So, derivative ng 2xy is just 2x. And yung partial derivative ni n with respect kay x is equal to derivative ng y squared with respect kay x, 0, plus derivative ng x squared with respect kay x, 2x. So, dahil equal sila, anong ibig sabihin nun? Therefore, the differential equation that we will solve is exact. So, hanapin ngayon natin ulit si function f na ang total differential ay equal dito. This term ay equal sa partial of f with respect kay x. And these terms ay equal sa partial derivative ni f with respect kay y. Ang goal again is to find the function f. Kanina, kinonsider natin yung first or yung partial derivative with respect kay x. What if i-consider natin to? May magbabago ba or same pa rin ba yung makukuha nating sagot? So, try natin gawin yon. Consider natin ito. The derivative of f is equal to quantity y squared plus x squared, partial of y. Solve for the integral of this equation. So, pag tinake mo ang integral nito, that is just a function f. Sulat natin na function siya ng x and y. So, ang integration ay with respect kay y. So, lahat ng hindi y ay iti-take natin as constant. Integral ng y squared with respect kay y cubed over 3 plus integral ng x squared with respect kay y. So, imagine nyo sa x squared ay parang constant lang na 1, ganyan. So, integral ng dy ay y. Plus, ano idadagdag natin ngayon dito? So, dahil ang integration ay with respect kay y, possible na dun sa differentiation na cancel yung function ng x. Kaya, magdadagdag tayo ng function na u as a function of x. So, parang siya yung constant sa indefinite integration. So, i-take natin ngayon yung partial derivative nito with respect kay x, then i-equate natin sa equation na to. So, the partial derivative of f with respect to y, or sorry, with respect to x equal to, differentiate natin to. So, ang differentiation is with respect kay x, kaya ito ay makakancel lang kasi iti-take natin siya as constant. Consider natin yung next. So, 0 plus the derivative of x squared y with respect kay x. Y is taken as constant. Derivative ng x squared is 2x plus derivative ng function ng x. So, u prime function of x, that is equal to this, 2xy. Simplify natin yung left side. 2xy plus u prime of x is equal to 2xy we can see that we can cancel 2xy. Therefore, u prime of x is equal to 0. Ano ngayon yung function ng x? Therefore, u is just equal to 0. So now the function f in terms of the variables x and y is just y cubed over 3 plus x squared y plus this is 0 equal to the constant c. Simplifying this by multiplying the whole equation by 3 and c, susulat ko na rin na divided by 3. So we have y cubed plus 3 x squared y equals c. So this is the general solution of the differential equation. For problem number 3, let's consider a differential equation in terms of other variables u and v. So we can take a look at this equation as m du plus n dv. To solve this equation, let's first check kung siya ba ay exact. So paano natin mag-check ngayon kung exact yung equation na to? Si m ay i-differentiate natin with respect to, so dahil kasama niya dito si du, i-differentiate natin siya with respect kay v. So the derivative of this term with respect to v, u is taken as constant. Derivative ng v cube is 3v squared minus derivative ng 3v, so 3. Simplify lang natin to, 6u v squared minus 3. Next, i-take naman natin yung partial derivative ni n with respect kay, so dahil kasama niya si dv, ang differentiation ay with respect kay u. So derivative of 3u squared v squared, with v squared ay taken as constant. So tip ko sa inyo, isulat nyo muna siya, at saka kayo mag-differentiate. Derivative ng u squared ay 2u minus derivative ng 3u with respect kay u, 3, plus derivative ng 4v with respect kay u. So taken as constant, kaya 0 na lang. Simplifying this, so dahil pareho sila, meaning exact yung ating differential equation. Dahil iba yung variable na ginamit natin for this, isulat natin yung definition niya. So dahil ang variables natin ay u and v, so ang hinahanap nating function ngayon dito is the function f in terms of the variables u and v. So ang total differential nito ay equal dito. And dahil ito ay 0, so siya ay equal sa isang constant. Define lang natin yung total differential ni f. That is equal to the partial of f with respect to u du plus the partial of f with respect to v dv, and the derivative of the constant c is 0. By comparing this equation with this, we can see that partial of f with respect to u is equal to these terms, and the partial of f with respect to v is equal to 3u squared v squared minus 3u plus 4v. So hanapin natin ngayon si f as a function of u and v. Gamitin natin pareho para mas masaya. So gamitin natin solution 1, yung kapag kinonsider natin yung partial of f with respect to u. I-write ko lang dito. So to solve for the function f, we will integrate. The integral of the derivative of f is f equals the integral of 2uv cubed with respect to u. So, si 2v cubed constant, the integral of u is u squared over 2 minus constant, kasi u ito. And the integral of du is just u. Plus, ano yung idadagdag nating function dito? So, tawagin nating phi sa function of v. Yung ina-add natin na to is parang siya yung constant na ina-add natin kapag nagpe-perform tayo ng indefinite integration. Simplify natin si f. So, we can cancel 2. So this is now u squared v cubed minus 3uv plus phi as the function of v. So kunin natin yung partial derivative ni f with respect kay v, then i-equate natin dun sa isa kanina. Partial derivative of this with respect to v, taken as constant. Derivative of v cubed is 3v squared minus constant. Derivative of v is 1 plus derivative ng phi as a function of v. So, phi prime as a function of v. And this is equal to 3u squared, v squared, minus 3u plus 4v. Simplify lang natin to. So, 3u squared, v squared, minus 3u plus phi prime as a function of v equals 3u squared, v squared, minus 3u plus 4v. Pwedeng i-cancel si 3u squared, v squared, negative 3u. So, we can see here that phi prime of v is equal to 4v. To solve for the function phi, again, we will just integrate. So, the integral of phi or d phi is equal to 4v dv. So, phi is equal to, integral of 4v dv is 2v squared Therefore, the function f that we're looking for, isama lang natin to, is equal to u squared v cubed minus 3uv plus 2v squared equals c. Let's do the second solution. Considering naman yung partial of f with respect kay v. So again, let's integrate. Integral of differential of f, that is f, equals integral of 3u squared v squared with respect to v. So constant si 3u squared, integral of v squared, v cubed over 3 minus 3u, so constant, integral ng dv, plus integral of 4v is 4v squared over 2 plus ano idadagdag natin? Tawagin natin z as a function of u. So simplifying this function f, we have u squared v cubed minus 3uv plus 2v squared plus z as a function u. Take natin yung partial derivative ni f with respect kay u and i-equate natin dito. So v cubed is taken as constant, derivative ni u squared, 2u v cubed minus derivative ni u is 1, so this will be negative 3v plus derivative ni 2v squared with respect kay u, 0, plus derivative ng z na function ng u with respect kay u ay first derivative ni z. And this is equal to 2u v cubed, ito yun, minus 3v. Makikita ninyo, pwede nating makancel si 2u v cubed and si 3v. Therefore, this just means that z prime of u is equal to 0. Therefore, yung z as a function ng u ay equal sa 0. So, ipalit natin to doon, and that will be the function f that we're looking for. U squared v cubed minus 3uv plus 2v squared, and that is equal to a constant. Makikita ninyo, pareho lang yung sagot na makukuha natin kahit sinong gamitin natin dun sa dalawang partial derivative. So this is the first method for solving exact equation. For our next video, I'll discuss about the grouping method and yung shortcut. So yun lang, galingan nyo palagi at huwag kakalimutang mag-like and subscribe sa Math 101.